So good day, guys. So we have a question like this. Said A going to B and is a reversible reaction. We have K for forward and we have K for backward, and that's also bring this. Actually, this question is brought out from CHM 323 past question Unilag students in 300 level, offering chemical kinetics. We can actually come across a question like this. So how can we prove this? Now, first thing is, what does each of these terms that we have here stand for? Actually, this our X is the amount of B that is gotten at any point of time. Shall we get? Or the amount of A that is decomposed. Don't forget that it is the amount of A that we remove that will give us the amount of B that is produced. This is actually the amount of B that is produced at equilibrium. That is XE. The amount of B produced at equilibrium, or the amount of A removed at equilibrium. And we know our Kf is actually, this is our exponential. Our Kf is the rate constant of the forward, Kb is the rate constant of the backward, and this T is our time. And this kind of reaction, please, is what we call the opposing reaction. Now, opposing reaction actually follows two principles. The first principle is that the part followed by A going to B, that is the part followed by the forward reaction, is also the part followed by the backward reaction. That's the first principle for opposing reaction. And number two, the second principle is that the rate of forward reaction is actually equal to the rate of backward reaction. Let's take note of that. And with that, we can also say, okay, the rate of chemical reaction, that is the X over the T, is actually equal to Ka, that is Kfa, please, minus, you can say our rate of chemical reaction is equals to Kfa minus Kb and B. So this is what we have for the rate of chemical reaction. Now, at equilibrium, said at equilibrium, the rate of forward reaction is equals to the rate of backward reaction. And that actually says, what that actually means is our Kae is equals to, that's Kfae is equals to Kb and Be. Are we good? Now, with that, we can also say our Kfae minus Kb Be is actually equal to what? Equal to 0. Let's take note that this is what the rate of forward reaction is equal to the rate of backward reaction, and at equilibrium, this minus this will actually give us 0. Okay, now let's move on from this reaction. We said our dx over dt is equals to Kf, we have A minus Kb, and then I have my what? I have my B. This is what I have. Now, this my A is the change in A. Now, how do I get the change in A? Don't forget that change in A is actually 80 and is actually equal to our A naught minus X. That means the amount of X, the amount of A that is actually decomposed. That is what 80 means. And this is the A we are having here. And the same thing applies for B, which is actually BT. BT is also equal to B naught plus X, not minus X this time. Why is it plus X? Because I am actually producing. So because of that, I have this. So now, instead of this A and this B, I can decide to impute this into them one by one. So I can say, okay, my dx over dt is equals to Kf, open bracket, we have my A naught minus X, and they have minus Kb, we have open bracket, we have B naught plus X. So this is what we have here. Very good. Now, at equilibrium, we have the concentration of A at equilibrium, and also have the concentration of B at equilibrium. So how do we get concentration of A at equilibrium? It will also be equals to A naught minus XE. Because to get the amount of A at equilibrium, we are going to minus the amount of A that is removed to form that concentration of A at equilibrium. And for BE2 will also be equals to B naught plus XE. So the amount of B that is produced, so that we can get the B at equilibrium. You can see that here we are using X because we are not talking about equilibrium weight. I can see A naught here, I can see B naught here. Why not make A naught and B naught the subject of the formula using these two things? So if I do that from here, just bring this X to this time. So I can say, okay, my A naught is actually equal to AE plus X, and my B naught will be equal to BE minus what? XE and E. Because we're talking about equilibrium now. So instead of this A naught, I can actually impute this. Instead of this B naught, I can actually impute this. So let's put them down one by one. So don't forget that my dx over dt will now be equal to my kf open bracket. Instead of this A naught now, I'm going to have AE plus XE minus X, that is remaining, minus I have my KB open bracket. Instead of this B naught, I'm going to be having BE minus XE, and then I have plus X, that is remaining. Are we good? Now let's try to open the bracket. So I'm going to have my dx over dt to be equals to, we have kf AE plus, that is kf times A, we have this. So I'm using this kf to multiply these two things because I don't want them to, I want to put them together. So I'm going to have kf open bracket xe minus x. Are we good? Now let's open this bracket. So if I use this to multiply this, I'm going to have minus kb, and then I have my be minus times minus. Now I want to use this kb to multiply these two things. If I bring this minus in, don't forget I'm going to have plus. So I have my plus kb open bracket. So we get this very well. I bring minus in, so this will turn to plus. So if I'm bringing minus in, minus times minus that I have here will give me a positive sign. I have xe minus times plus that I have here will give me a minus sign, that has x. Are we good? So now let's now try to like rearrange this. I'm going to have dx over dt to now be equal to kf ae. Now this is kb minus e. They look alike. I can put it by the side, kb and be, and then we have plus kf open bracket xe minus x, and they have plus kb open bracket, so xe minus x. So we have that. Now let's see. So we have the x over dt now to be equals to, look at kf ae minus kb be. Let's check up here. Kf ae minus kbe, what did it give us? Give us 0. So these two things will automatically give us 0. So we are eliminating this out. What we are working with now will now be these two things. So we have kf, this is xe minus x, this xe minus a. We can factorize it out. So I'm going to have xe minus x, close your bracket, open bracket, we have kf plus b, kf plus kb. What I just did is factorization. This and this are common, bring them out. I have kf plus kb. So we have this. The next thing now is we are going to cross multiply. So let me do it one after the other so we can get it together. Good. So here I have dx over dt to be equal to xe minus x, open bracket, kf plus kb. So let's rearrange. Bring x here and bring dt there. So I'm going to have dx over xe minus x to be equal to, I have kf plus kb, and then I have my dt. The next thing now to do is now integrate both sides. So let's integrate both sides. If I integrate both sides, I'm going to have the integral of dx over xe minus x to be equal to kf and kb are constant, so I can bring them, and then I have the integral of dt. Now this is actually good. So this is actually at from 0 to x, and this from 0 to t. Don't forget, why is it from 0 to x? Because this x signifies the amount of a that is removed. So when I start, I have not removed any a, so till the amount of a are what I removed. And when I started, so the time is 0 until the time we end the reaction. Do you understand? So if I integrate 1 over xe minus x, I am going to have minus ln xe minus x. Do you understand? And then we have upper and lower limits, which is what? X and 0, which is equals to, we have kf plus kb. This is 1, invisible 1, and this is 2 raised to power 0. 1 is 2 raised to power 0. If I integrate 2 raised to power 0, I'm going to have my t. The upper limit are t and what? 0. Now let's now impute this one by one. Then I'm going to have minus, we have ln, I have xe, put my x there now. I'm going to have minus x, minus, we have open brackets, we have minus ln, open brackets, xe minus, instead of this x now put 0. What I just did is upper limit minus lower limit. The upper limit is x, the lower limit is 0. Don't forget, what we are just substituting for is the 0. Do you understand? This is the x, so I put x there and I put 0. Everything is equals to, I'm going to have my kf plus my ke, and then I have my open bracket t minus 0. So let's move on. So let's bring out minus. I have a lot of minus. Let me just bring minus out. So I'm going to have ln, open bracket, we have xe minus x. If I bring out one of this minus, it will mean just one minus, and then I have ln, open bracket, xe alone, because xe minus 0 is xe, close your bracket, is equals to, I'm going to have open bracket kf plus kb. Please, this is kb, not ke. Kb, good, this kb. And then I have t minus 0 is what? I have my t. Confirm. So here I'm going to have minus, open bracket. If I have minus in front of 2 ln, this will give me ln, open bracket, xe minus x over xe, close our bracket. And then I have my kf plus kb, and I have my t. Do you get? Now let's bring this minus to this side. If I bring this minus to this side, I'm going to have ln, and then I have my xe minus x over xe, close the bracket. Then I have my minus kf plus kb, and I have my what? My t. Now if ln, don't forget that what they asked us to find is to find x. So what I'm just doing now is make s subject of the formula, because the formula asks us to look for x. So bring ln, bring it to this side. So I'm going to have xe minus x over xe is equals to e raised to power minus, we have kf plus kb, and I have my what? My t. This is what I have it. So if I cross multiply, I'm going to have xe minus x is equals to xe e raised to power minus kf. So I have kf plus kb, and then I have my what? My t. So next thing is bring this x, bring it to this side, bring everything we have here, bring them to this side. So if I bring this s to this side, and then I have my xe minus, because if this cross to this side, it turns to minus xe e raised to power minus, we have kf plus kb, good, is equals to, if s cross, we have plus x. So then I can actually see my x, that is this x I wrote here, is equal to this x, I can factorize it out. I have my xe, open bracket, here what will be remaining is 1, and then I have my this minus, and then we have e raised to power, then we have open bracket kf plus kb, We have t here, this t, so we have close your bracket, your t. Good. So this is what we have, and then let's compare with what they actually asked us to find. So they asked us to find x is equals to xe. We have 1 minus kf plus kbt. So we have been able to look for that. So that's how to look for this. I hope we have been able to break this down, so you can just practice this on your own with this kindergarten explanation. Thank you so much.